Hi everyone, this is Mrs. GA, and today we're going to talk about complex numbers. So a complex number is an expression that can be written in the form of a plus bi, and we call a the real part of your complex number, and we call b the imaginary part. So the real part should always come before the imaginary part. This is also a quick reminder of what I is. So by definition, I is equal to the square root of -1. And by definition, I squared will always equal -1. That means that I cubed is like saying -1 times I, so it becomes -I. And then I to the fourth is like saying I squared times I squared, so it's +1. So we'll use these definitions to help us simplify higher powers of I. Essentially, you're going to take out as many powers of I to the fourth as you can, and then your answer will be one of these three things. Okay, let's see if we can simplify the following expressions. So here we're going to multiply these two binomials. You start by multiplying just like any other binomials with variables. So we'll do FOIL. So we have 12. And then we have minus 6i plus 20i, so plus 14i. And then here we have minus 10i squared. Now from here we just need to simplify, so hopefully we remember that I squared is always going to simplify to -1. So this actually becomes 12 plus 14i plus 10, because -10 times -1, and then we'll just combine like terms, and we'll make sure to put our real number first, so 22, and then our imaginary number 14i second. Okay, now let's see if we can simplify I to the 23rd. So remember, anytime we have I to the fourth, it becomes 1. So I'm going to see if we can make the maximum groups of I to the fourth. So I know that the maximum would be at 20 if I have 23, because that's the highest power of 4. So I can write this as I to the fourth to the fifth, which becomes I to the 20th. And then what I have left is I cubed. And again, I to the fourth by definition is just 1. So this all simplifies to 1. And what I have left is I cubed. So remember, by definition, I cubed just becomes -I. And again, the reason why this works is because we split it up into I squared and I. And we remember that I squared becomes -1. Okay, let's see if we can do the same for I to the power of 41. So we want to take out as many groups of 4 as we can. So I'll take out 10 groups of that, as I to the 4th to the 10th is I to the 40th, which means that all I have left is I. So this just simplifies to I. And there you have it. Okay, now we're going to talk about how to divide complex numbers. So if you have an expression like this, where we have a complex number divided by a complex number, we can simplify this by multiplying the numerator and denominator by what's called the complex conjugate. So hopefully you remember the word conjugate. You use that when you're rationalizing the denominator, when you have some type of radical in your denominator. So here, a complex conjugate, we just change the middle sign of our denominator. So the complex conjugate of c plus di is c minus di. So for a conjugate, the only thing that changes is your middle sign. And if you multiply the numerator and denominator by this, you'll see that your i's will disappear from your denominator. So that's our goal. Our final answer should never have imaginary numbers in the denominator. All right, let's give this a try. So here we can simplify this again by multiplying the numerator and the denominator by our complex conjugate. So the complex conjugate of our denominator in this case will be 1 plus 2i. So again, if we do this correctly, we should no longer have any i's in our denominator. All right, let's start by multiplying out the top. So we have 3 times 1, which is 3. And then we have 6i plus 5i, so that gives us plus 11i. And then we have plus 10i squared, which we'll simplify in the next step. And then if I multiply out the denominator, I have 1. And then here you can see I have plus 2i minus 2i, so those will cancel out. And then what we have left is minus 4i squared. So now we're going to go through and simplify I squared, which remember becomes negative 1. So we have 3 plus 11i minus 10 over 1 plus 4. So these negative ones change the sign of both terms. And then let's write these as complex numbers. So 3 minus 10 is negative 7 plus 11i all over 5. And then just to make sure it's a full complex number, we do want to separate the real and the imaginary. So I'm just going to write it like this. Negative 7/5 plus 11/5 I. And this will be our final answer. Okay, so at this point I'm going to ask you to pause the video and give this one a try, and then we'll check your answer in just a few seconds. Okay, so in this case, think of this as 0 plus 4i, so our complex conjugate would be negative 4i. So multiply it out, simplify I squared, and then write it as a complex number, so your real and imaginary parts should be separate. All right, so now we're going to be working with square roots of negative numbers. So we're going to be multiplying these two binomials out. So whenever you're working with any square roots, especially ones with negative numbers, we're going to want to simplify them before we start multiplying. So let's start by simplifying square root of 12. So that becomes 2 root 3. I can simplify this by writing it as minus I root 3. Remember, by definition, I is the square root of negative 1. So whenever you see a negative inside, we put an I on the outside to help simplify. And then this becomes 3 plus I times 2, so I'll say 2i. So the I is from the negative, and the square root of 4 is 2. So now I'm going to FOIL this out, multiply it out. So 2 root 3 times 3 is 6 root 3. And then we have plus 4i root 3. And then we have minus 3i root 3. And then we have minus 2i squared root 3. And now I'm going to simplify what we have. So we can simplify this. So we have 6 root 3, and I'm going to write it next to it because I'm going to combine them in the next step, plus 2 root 3. Remember, I squared becomes negative 1. And then I can combine these two terms, my two imaginary terms. So I have 4i minus 3i just gives me plus I root 3. And then last, I'm going to combine my real terms. So 6 plus 2 becomes 8 root 3 plus I root 3. And so this is our complex answer. We have the real part and the imaginary part. So again, here I'm going to ask you to pause the video and see if you can multiply this out. And we'll check in just a few seconds. Okay, go ahead and check your answer here. Again, I recommend just multiplying everything out and then start simplifying as you go. So remember, this term, negative 3i squared root 7, becomes positive 3 root 7 because of the I squared. And then you just combine the real parts and then combine the imaginary parts. Okay, the last thing we're going to do is solve quadratics that have complex solutions. So we're going to do two different approaches here. This one, I'm going to try to use the square root approach. So I'm going to isolate my squared term, and then I'm going to take the plus or minus square root of both sides. So here you can see, since we have a negative inside of our square root, we are going to have an imaginary number. So our x is going to equal plus or minus 3i. Okay, for this next one, hopefully you see that we can't factor this, so we should try a different approach. So I'm going to do the quadratic formula. So let's substitute our values. So here, if I simplify more, I have negative 4 plus or minus the square root of. Here I have 16 minus 20, so I have negative 4. And I forgot to substitute here, 2 times 1. Okay, all over 2. Let's simplify our square root. So we have negative 4 plus or minus 2i all over 2. And then I can divide both terms by 2. So negative 2 plus or minus I. So remember, this is just like solving any other quadratic equation. You just have to do that extra step of simplifying a square root of a negative. Okay, here's our last example, so please pause the video and give this one a try, and please make sure your final answer is written as a complex number. All right, go ahead and check here. So after you substitute and simplify, you get the square root of negative 16, so that's how you know you're going to have a complex answer. So that becomes 4i. So we have 24 plus or minus 4i all over 8, which becomes 3 plus or minus 1/2 I. So make sure to separate the real and the imaginary to have a true complex number. All right, that is all for today's video. Thank you so much for watching.